Hello, everyone, ladies and gentlemen. All of us have played a game. It's called Tic-Tac-Toe. We used to play it on paper, on the corner of our notebooks, or even on the blackboard when the teacher wasn't watching. But now we are not just players. We are problem solvers. We think in code. We build with logic, and we bring ideas to life. So today we are going to tackle the ultimate nostalgic challenge. Can we bring back the old school fun using code? Yes. And not only that, we are going to write it in Python and play it in our very own terminal. We will build a simple, clean version of tic-tac-toe using classes, conditionals, loops, and smart Python tricks. By the end of this, you will not only have a working game, but you will be several steps closer to becoming a Python hero. The question is, why are we doing it this way? Because this project is not just about having fun, it's about learning. You will understand how to structure your code using classes. You will get better at working with dictionaries. You will see how to keep your logic clean and modular. And you will gain confidence writing real Python projects. So, in this video, um, for you for doing the structure of the game, we are going to use OOP. So before we jump into the code, I want to tell you a bit about OOP. OOP, it's object oriented programming. In Python, we can write code in different styles. Procedural programming, you write functions and variables in a in top to the bottom script. Everything is in one flow. But object oriented programming, or OOP, in that you group related data, uh, which are the variables, and behavior functions inside something called a class. Think of a class as a blueprint. From the blueprint, you can create objects. These are like a real usable version of the blueprint that can store their own data and do the things. And I want to say why OOP for uh, our game. By the way, I call it PyPacPoe because we write it in Python, so I changed uh, uh, to a funnier name by PyPacPoe. So why we use OOP? We want all the game data, for example, our board, score, turn, winner, and all game logic, the methods for playing, printing, checking the winner in one place. That place is our PyPacPo class. So when we have it, we can start the game simply by creating one object from it and calling it by start method, which is we are going to define it later. So, as a refreshment, before we start building the game, I want to tell you a bit about the game. Of course, all of us we know that it's a simple three by three grid, nine little squares. Two players take turns. One is O, one is X, and the goal is to get three in a row, whether that's horizontally or vertically or diagonal. If the board flips up and nobody gets three, it's a tie. So this is the logic for the game. So now we are going to write the code and build the game. But always, this is my recommendation. Before jump into the code, take a deep breath and make a strategy. Write whatever you want to do. Uh, in order not to lose the time, I wrote down some mm, as a bullet point here our strategy. So because every Python hero needs a battle strategy, so we need a strategy. What are we building? So we are going to build a terminal-based tic-tac-toe game, fully interactive, and two players can play each other by using object-oriented programming. We will create a class called PyPacPoe, and inside it we will define our methods and variables. So we need a place to store the data, and we need uh, the behaviors between them, which are the functions, but in the class we call it methods. So, so we are going to use object-oriented programming. We will create a class, PyPacPo, and we have a game state dictionary. It's a place that we track everything and we store the data. A method to start the game, a method to receive the board for each round, a loop that runs the game logic, a method to print the game board, a method to collect and validate players' move, and a method to check for a winner, and also a method to handle and display the results. I want to give you another recommendation before writing the whole code, like the script from the scratch. You need to structure them first. So uh, it's a a very good method to write a script. So we are going to structure our game. So based on our strategy, we said we need a class. So class PyPacPo. So always when we start the classes, we do the uppercase. So class PyPacPo, and we say okay, pause. I'm going to explain you everything later, but we just write a pause because we don't want any problems for now. And then we are going to define our behavior or the functions or the methods in class. So after initializing the game, we need to start the game. So we say def start self and pause. So we just want to grade the players, ask for target of the wins, and the kick off the first round, stuff like this. And then we say we need to play the game. So here we, for example, we run one full round, receive the loop and turns, and check the winner, finish everything. So this is the play game method here. And after this, we need to initialize the game again. So we need init game. And also we need to print the board because the players should see the board. So we render the 3 by 3 board in the terminal. So we say the method is print board, And then we need to get the moves from the player. So we need get move, and after this we need to get the winner. So if we see someone's is a winner, so we need uh, to understand who's the winner. So we need another method which is get winner and pause, and then at the end we need to handle the winner. So say handle winner. So here we need to show final board, the announcement, results, update the score, and everything. And then we do the indentation in Python. As a refreshment, indentation is very important. So now we're done with the game. So we have a game. It's a PyPacPoe class, and we need to start the game. So this is the structure: initializing the game, start, play the game, and then the behavior of the initializing the game, print the board, get moves, get winner, handle winner, and then again we use the uh, class to make an object and start the game. So that's the structure of the game. So we are going to fill those gaps step by step. So first step, we create a class. We initialize the game state. We are setting up the foundation for our game by creating this class, and uh, in this class we hold all our game data and logic in one place. That's the power of the class in Python. uh, it's like building the frame of the house before adding any rooms or furniture. So we have this class, and first method is the initializing the game. So this defines our class, the blueprint for our game. Every functions in the class is called method, as I said before, and the datas will live inside this class. So as I said, we need to have a state. So I'm going to clean this path here and write self dot state, which is our dictionary. And yeah, this is our dictionary here, the place that we store all data. So what kind of data we need? All of you know that in dictionaries we have key and value. So what keys we need here? We need score. So we are going to write the values later, but I just want to show what keys we have. We have number of wins. We have winner. We have a board, and finally we have the term. So those are the keys that we need for our dictionary. So what kind of values we need? So in this score, we need X, O, and tie. So we say X, which is 0. So the score is another dictionary in our dictionary. So it's a nested dictionary here. And the value is 0. We have O. Let me write it in the capital letter. Letter. We have O. The value for this is 0 because we haven't started yet. And we got tie. And that value is 0 again. We need a comma here. And then we go to the number of wins. So number of wins is the when we start the game, we gonna ask the player how many wins you want uh, to win finally the game. So at the moment it's 0 because we haven't started game yet. And then the winner is none because we don't know yet who's the winner. And now we need to uh, add the value for the board. So our board is another dictionary. We have 3 by 3 grid. So here we need another dictionary with the keys A1, the value is none, and then B1, none, then C1, none, and then we have okay, and then we have A2, none, B2, none, and C2 we also have A3, B3, and C3. Okay, so this is our board, and now we have the term. So we need to add a value for the term. So we start with X. So what we did here in Python, uh, as I said, we always capitalize the class for each word here, and then we had a initialize here to initialize our state here. So it's a special method in Python that runs automatically when you create a new object from the class. Uh, and the self, it's a parameter here, represent the specific object we are creating. It lets us store data that belongs to that object. So whatever we store here, as you can see, we say self data state, which means state belongs to this class here. And then, as we said, state is a dictionary that holds all the game data in one organized place. And we use dictionary because it lets us store key value pair. As you see here, we have score, non-win, winner, board, and turn as keys and values for them. And also we can track uh, the game. And also, yeah. So by the end of this step, we have a class with a constructor that steps up all data we need for our game to run. So this is our first step. So successfully we could write the first method in this class. So now we go to the step 2. We need to start the game. So how we can start the game? Probably it's the easiest method in this class. We just want to say hello to the players and say, okay, you can play this game, and ask the numbers of win. So I'm going to clear this path and say print something like this, and then print, for example, let's play high back. Oh, and then we print again those beautiful dashes here. Let me copy this to have the same number of dashes here. And then, okay, I also add a new line here. So you know that backslash n is a new line in Python. And after this, I want to ask the player how many wins to play to. So I say self, because as I said, self means uh, this object is uh, belonging to that one. So I say self state. We have num wins, which is here. So you know that this method, by this method, we can have access to the dictionary key and value, equals to I say integer because whatever players say it's a string, so we need to convert it to the integer. We say input, for example, how many wins to play to. Okay. And now we have self dot play game. Okay, so here we just print something and we ask the players how many wins to play, and then we need to start the game. So we need to play the game. So run the next method that we have it here. We haven't defined yet. So one more time, I want to explain this. Uh, we are defining the start method inside this class. This is the entry point for running the whole game flow. And then we print something here, and in the input, uh, mm, input shows a prompt and return text as a string. So we wrap it into the uh, int, or uh, the to convert it to the integer, because we will compare scores numerically later. So, and then we need to start the game. Now that we know the target number of wins, we jump straight into the first round. We will now implement play game in the next step that we are doing now. Okay, so now we are going to write this method, uh, play game. First, I'm going to say self dot init game. That's the next one we are going to define later. Um, this method, it controls the full game round. So we have this self dot init game because we want to receive the board sets and turn it back to X and clears any previous winner. So that's why here we say self.init game. And then we need to uh, have a loop here. Why? Because until we don't have a winner, sorry, until the move hasn't done properly, we need to continue asking player to put the right uh, square name, like B1 or B2 or whatever. So we say while not self.state winner self.print board. So until we don't have a winner, we print the board. And then we say move, the variable move here, it's self get move. And then we say self dot state board move. Sorry, it's equal to self dot state term, and then self dot state term equals to O if self dot state term equals to x, else x. So I'm going to explain this all in a bit. And then we say self.state winner self.get win. And after that, we handle the winner. So once again, uh, indentation is very important. So what we did here, we have a loop here. This loop keeps running as long as there is no winner. So when we say not self.state winner, means the value is still none. As soon as self.state winner becomes X or O or tie, the loop stops. And also we need to display the board. So we have the self.print board one displays the current game board in the terminal so the player can see state before making a move. And also we will define print board later very soon. And here we have move. So we ask the current player for the move and validate his move. So it returns something like B2 or A2 or whatever. And then we need to get the move. And so we will define it later. We have it here as you see. We'll define the move later. Don't worry about this. And in the next line, we have in this line, we update the game board dictionary to mark the chosen cell with the current player symbol, X or O. For example, if move is B2 and turn is X, then the board entry B2 becomes X. So we need to show that the player X choose B2. And also here we have in this line, by the way, in Python, this line, this method calls ternary expression in Python. We can read it as if the current if the current term is x, make it o, otherwise make it x. So it's another uh, cleaner version. Let me write write it in another version to show you what does it mean. So this line, it's like we say if self dot state term equals to x, oh sorry, x, self dot state term o, else self dot state term equals to x. So this line says this: if self dot state term equals to x, so give the term to O. If it's not x, which means the term is x. This is exactly which we have here. This this method is called, as I said, ternary expression in Python, which is good to know. Okay, so that was our step to define the play game method in our class. So now we have the next step. Uh, all right. Now we need a quick reset button before each round to start. I want a clean board. X to go first and no winner set. That's it. Simple and practical. So we need to restart. We need to refresh the board. So we need the board. We say self dot state board equals to, we need to refresh it. I'm going to copy this again here because it's exactly the same. Let me clean it up a bit. So we refresh the board. Again, we need to give the term and we need to uh, define the win. So we say self data state term is by x, and self dot state winner, no. Okay, quickly. Here we define a small helper that prepares everything for a new round. When we say self.state board here, I'm rebuilding the board from scratch. Those keys like A1 or B2 are just labels for the 9 squares on our 3 by 3 grid. And every value is none, which means they are empty. Later, we will flip none to X or O. When someone plays, we'll flip it to O's or X's. And then here, when we say self.state turn X, X always starts, keeps telling things like easy. Yeah. And also we say self.state winner none, which means we haven't started, no winner at the beginning of the round, obviously. So we want to keep it empty. Okay, we are going to close to the end. You see, we have only 4 methods left. So now we need to print the board. This one is a bit simple, but a bit tricky. Now I want the game to actually show the board in the terminal. It's super simple, a clean 3 by 3 grid with A, B, C across the top and 1, 2, 3 down the side, and each cell showing X, O, or just the space if it's empty. So, uh, okay, because I don't want to uh, mm, I want to make a shortcut here so I don't keep typing like self.state board like this, self.state board to access the board. I am going to define a variable which is b. I just say b is self.state board here. So to make it a shortcut here, it just um, to call it because you will see we are going to need this a lot in this method, so I just made a shortcut here. And now I am going to print the board, actual board in the terminal. So we say print, and here of course you know about the making comments, sorry, writing this string. So we have two quotation marks, uh, let me, like this, we have quotation marks here, but now I am going to use a triple quoted string so I can write multiple lines exactly as I want them to appear. So I'm going to use triple quoted string like this. So Between them, I'm going to write whatever I want, so and it appears exactly the same. And also inside the string, I'm going to show you by writing the code first. So we have A, B, and C, and then here we have 1, 2, 3. So A, B, C, 1, 2, 3. We are going to print our columns and rows here. So I add a curly bracket. So it means just a placeholder. Just copy this one. Clean. Mm, okay. And I'm going to use a built-in method here, which is format. So I say dot format. So what format does exactly? Um, it takes the value we pass in the format and fills each curly bracket from left to right. So I'm going to show you in a quick example here. So if we say here print hello and then curly bracket and dot format ben, if you print this, it's gonna print hello Ben. This is exactly what we are going to do here. So we added curly brackets here and use the format function to get the value and replace it in the empty, the placeholder, which is empty now. Okay, here is a bit tricky. Uh, how to get the how to replace the placeholder. So we say uh, we need to convert it to the string. So we say string b, which is our board, and uh, we define the variable b. We say b1 or empty. And then again, string b, b1 or empty. Okay. And then we write it here. String b, c1 or hmm? So one, two, three, four. 2, 3, 4. We need 9. Let me just copy this. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have uh so this one is should be A1, A1, B1, C1, A2, B2, C2, and then A3, B3, and C3. A1, B1, C1, A2, B2, C2, A3 is B2, and C3. So this is the board. And yeah, so let's explain this one more time. So inside the format, so as I said, what does format do? Format takes the data and replace it with a placeholder here. So it's a built-in method in Python. So A1 or for example BA1, it can be X or O or none. The or here, when we say or empty, uh, what does it mean? If it's empty, which is none, show a space. So if it's none, it just show nothing because we don't want to show none in the terminal. So we say this. And we wrap it in the string method here to make sure it's always a string, even though X or and O are already string, but none is not. So this avoids error when we printing. Okay, so this is our um, step to sorry, to define the board here. So we said print board. We define the B here, and then we print it, and we use the format method here to replace the placeholders. Okay, let me clean it a bit. So now we go to the next step. Now we need um, to have to get the players move. We will prompt the current player, read what they type, normalize it to lowercase, make sure it's real square on the board, and that the square is empty. If it's valid, we use it. If not, we complain and ask again. So we are going to write. We are going to say, oh, while true, do you remember move? So we say move input f string player self dot state turn mhm, and move. We can give an example like example b2. And now we need to make sure, for example, we said b2, but maybe the player writes like capital B. So by lower method, we can solve this issue. Okay. And now we say if move in self dot state board and not self dot state board move return move, else print something like box move, try again. Okay. So what we did here, we are defining a helper that won't let you leave until you give a valid move. So we need a valid move from the player. So we say while true, endless loop. we use while loop here by purpose. We will only break out by returning a valid move. If the input's bad, we loop and ask again and again. Here we say uh, the move, we need to prompt the player. So we say we have input, we use the f string here, it drops the current player x or right into the message. And also we use the lower uh, built-in function, makes the input case insensitive. So b2 or by capital letter or small letter, it's the same. And now we have a conditional expression here. We say if move in self board and not self dot state board move. So this method, as you know, we can access the dictionary by square brackets. In Python dictionaries, as you know, it's a key value pair, and you use square bracket to get the value for a key. Uh, in here, we use that method. So by square bracket, we access to the value of the board key. And yeah, so if it's uh, in the board, so it returns the move, else it prints it's not a valid um, move. So we say bugs move, try again. Until we have a valid move, the loop continues and continues. Okay, we are closing to the end. Now we need to get the winner. So how we can get the winner? After every move, we need to check the board and figure it out. Did someone win? Did we have a tie, or should we keep playing? In tic-tac-toe, you win when you get three of your marks in a row, and that can happen horizontally, vertically, or diagonally. So in this step, we are basically scanning the board for any of those, the winning lines, I mean. If we found one, we return the winner's symbol. If the board's full but no one's won, we can call it a tie. Otherwise, we just keep going. So if we don't have a winner and don't have a tie, we keep going. So because I'm going to use again the board key from the state, always remember the structure. We have a state, we store all the data inside, and one of the key of the state, which is a dictionary, is a board. So we need self dot state board here because we are going to use it a lot in this method. So I'm going to define a variable b here as a word. This b means the uh, mm, key of the state dictionary for this class. Okay, as a refreshment, before I write the codes, uh, I'm going to remember you about a method in Python. So if you want to access to the dictionary value, we have a method like b dot values. So by this method, it's a built-in method in Python for dictionaries that gives you all the values without a key. So if I want to access to the board, the keys of the board, the values of the board, I'm going to use this method. So, and now we need to check the rows, three rows, horizontal, vertical, or diagonal. How we can check it? So I'm going to say here, if B, which is the board A1, okay, and BA1 equals to B1 equals to BC1. So this is the first row. Return BA1. So by this method, we check the first three cells in one row, A1, B1, and C1. So because we need to check 1, 2, 3, 4, 5, 6, 7, 8 times, I'm going to copy this 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so the first was A1, B1, C1. So it returns A1, which is the same as uh, uh, the first row. And then we have A2, 2, B2, and C2. And then we have A3, B3, and C3. Okay, now it's a bit tricky. A1, and then we have, uh, okay, A1, and then we have A2, and then we have A3, and here should be also A3. Uh, so let me A1, A2, A3, A1, and then we have B1, b2 and uh, b1 b2 b3 and returns b1. Let me fix this one. Oh, here is a b3. So we have here a1, so it returns a2 here, and this one should returns a3, and this one again returns a1, and here returns b1. Okay, and then we have c1, c1, c2, c3 returns c1, and now we have the diagonally. We have a1, a1, b2, c3. So it returns a1, and then we have c1, c1, b2, and a3. Okay, let me check. We have a1, b1, c1 returns a1, a2, b2, c2 returns a2, a3, b3, c3 returns a3, a1, a2, a3, b1, b2, b3, c1, c2, c3, and then a1, b2, c3, and then c1, b2, a3 returns c1. Okay, and if there is no match, so which means that we don't have a winner, so we need to return a tie. So we say return, indentation is important, don't forget, return none, and if not, in b dot value we access to the value, else t, which means tie. Okay, so let's go line by line. We define a method to get the winner. This is our referee. Every time someone makes a move, this method decides if the round should end, or we have a winner or not. Then we define a variable here, just a shortcut, so we won't keep typing self.state, or just imagine I had to write all those things here again and again. And here we are going to check the winning um, uh, condition. So we say if this cell A1 and this one, and this one equals, return B1, which means we have a winner. Here is what's going on here. When we say BA1, look at the value in the top left square. If it's none, which means empty, we skip the check because three empties in a row isn't a win. And also, this method, when we say BA1 equals to BB1 and equals to BC1, it's called a chained comparison in Python. Python checks that all three cells have the same value, all X or all O, and then return BA1. If this line is a win, we give back the value in BA1. So we give that value in the cell. And then we repeat the same pattern again and again for all rows and columns and both diagonals here. And here also we need to say, after our check, we need to say keep playing or it's a tie. By b value here, we say this is a, as I said before, it's a built-in function in Python for to access the uh, value of a key in the dictionaries. And if there is at least, here we say, if there is at least one empty cell, we know the game's not over yet. So we return none to keep playing. If there are no none value left, that means the board is full, no winner was found, so it's a tie. So basically, get winner method here is just a series of, does this line have the same symbol in all three spots? Checks if it does, we send back that symbol to say who won. If nobody's won yet and there is a space, return none and keep playing. If the board's full and no one won, return T for tie. So now we know who's the winner. We need to go to the next step, which is the last one. All right. Once a round ends, we want to do three things: show the final board, announce the result, and update the scoreboard. If someone has hit the target, you remember we asked them in the beginning of the game. If someone has hit the target number of wins for the match, we celebrate and stop. If not, we spin up the next round. So, going to have again, we need to print the board. First, we show the final board so everyone can see how the round ended. So we say self.print board. Okay. And now, if the winner is tie, is T, that means tie. So you remember, as a return, if we have T, that means a tie. So we need to print a tie message. Otherwise, we print who won the round. For example, we need to say player X wins the game, or player O wins the game, or whatever. How we can say that? So we print the board, the last version of the board, and then we want to say it's a who's the winner, or if it's a tie or something. We say if self dot state winner, we want to access the winner key, equals to t, print something, for example, another tie. Okay. If it's not a tie, else, what should we print here? We print player. So we want to know which one, O or X. So we need to uh, access the um, winner. So we say self dot state winner again wins the game slash N. Okay, so we check the winner if it's equal to t. We say another tie, and then we check the winner. Uh, we print the player X or O. It's a winner. So by this method, we access the winner. So we need to update the score. You remember the very first, we have a score here. You remember in our dictionary we had a score. So X was 0, O 0, and tie 0 because we haven't played yet. But now we need to update it. So we say indentation. We say self dot state score. We need to access the uh, X or O. So as I said, the method in dictionary. So we say self dot state winner could be X or O. One. So I don't repeat this one. You know that it means in Python, if you want to write something like b equals to b plus 1, you can write it b plus 1. So this is exactly the same as this one. So we update this score, and now we need to print something. We need to have the announcements. So say print, and I use fstring score n, then fstring player x self that state score x. So we access to the X score here. And then we say fs string player o o, and then we say fs string, instead of player we say ties self to this day score and t. And then maybe we can add a new line here as well. So we print this, and also now we need to congrats the player as well. So we say another print. We need another print, but before, we need to say if self dot state score x equals to self dot state num means, or self dot state or o equals to self dot state num wins, then print. If you have a winner though, print again fs string, maybe in a new line we say congrats, congrats to player, which player again, we need self dot state winner, and for win. Yeah, that's it. And maybe we use another fs string to say self dot state num wins, um, greater than 1, else nothing. Okay, and then this is our if else. If we don't have a winner, we need to continue playing. Self dot play game. All right. So let's go line by line here. First, we need to show the final board to everyone. They can see how the round ended. So we say if self dot state winner equals to tie t, we print this. Else we print the winner. Who's the winner? X or O? We can access to the winner by this method in dictionaries. Here also we update the score. You remember in the dictionary we had a key which is score. And then we we print uh, the the player's score, like how many X has it, how many O's has it, and how many ties, the number of wins here. So we access to the number of wins by uh, by this way in the dictionary. How many scores each player has it and how many times. And then we need to check the X or O, which one reach the uh, number of wins. So if someone reached, so we say congratulations and the play stops. Otherwise, we continue playing. All right, let me check one more time. Okay. So now we finished our method. So we need to uh, uh, launch the game from the terminal. So as we wrote it before, we have game PyPacPoe, which is our object. It creates a new game. And we have a start method. So we define the start method. So everything is fine now. So this one creates an instance or an object of our PyPacPoe class. The moment we do this, Python automatically calls the, uh, you remember, init method here, this one, inside the class, which sets up our state dictionary and uh, everything else we need before playing. We call the variable game, so it's easy to reference, but we could technically call it anything. Just, yeah, we can call it margarita or whatever. And here with game.start, we tell that game object to run. It's a start method, the one where we print a welcome message, ask how many wins to play to, and then start the first round. So this kick off the full chain of events, like start and then play game and then moves and then turns and the winner checking and score updates and everything, but everything starts from here. So that's all. Just two lines to take our blueprint and turn it into a living that runs in our terminal. From here, you can play as much as you want, stop when you want, and uh, you can say this to your friends, and you can say that um, I can, I developed my Python skills by this. So now let's play the game and see what we have done here. So I run the terminal here. As you can see, it says how many wins to play. I say just one, and it shows the board and players X move example B2. You remember we use a lowercase, so I just write A1 here to see if it works or not. Yeah, it worked. And as you can see here, we see X in the first cell. And then now is O's move turn. O says, uh, let's say B1, and then you can see O here, and then as X, I say A2, you see X here, and then O says B, let's say C3, you see O here, and now it's the time to say as X A3. So we have 3X in a column here. So as you can see, we have a score here, player X1, player O0, and tie 0. Congrats to player X for winning one game. Yeah, that's the game. Before we wrap this up, we could totally take PyPacPoe even further. I'm talking about adding some cool extra features just for fun. For example, a single player mode with an AI opponent, even simple one that picks random moves, or a smarter one using the minimax algorithm, and etc. etc. Also, we can custom the board size. We can undo last move. We can save and load matches. We can do it even colorful terminal output, and also we can use animated text effect. So this is the logic. We can use the same logic for the uh, mm, better and more user friendly, and we can do a lot. But the most important thing that we need to learn the logic. Uh, that's why I wanted to walk through this code, and yeah, it is your very own PyPacPo game in Python, fully playable right inside your terminal. We didn't just make a game, but we wanted to learn object-oriented programming. We wanted to work with dictionaries, write cleaning modular code, using loops and conditional expressions, and even handle user input like a profession. Now, next time someone asks you Python is just for boring scripts and for data analysis and stuff, you can show them this and challenge them to a match. If you enjoyed building this with me, drop a like, subscribe for more fun Python projects, and leave a comment with your own bonus ideas. And until next time, keep coding, keep learning, and keep leveling up on your journey to becoming a Python hero. Thank you for watching this video.